All right, let's get started here. I believe, yeah, we're on the next page here. Copy. Um, let's do this batch here. Okay. Right. 187. Actually, what are we doing here? In the following use of, oh yeah. Hmm. Oh, did I do 187 last time? I don't think I did. So I'm just going to separate out 187. Um, we want a graph. Okay, let's open up derives. Quickest way to make a graph. I Maxima is okay, but to be honest, I'm a bit old school. I really like Derive. It's so simple. It's so small as a program. It's only a few megabytes. Just works so well. Okay. Um, okay. X minus 4. Okay. Minus 2. Okay. So the limit here should be 2 at 8. So let's go in. Okay. Oh yeah, what I did last time I remember is I helped by marking it out there. Okay. And then square root. No, y equals 2.1 and then 1.9. So here about 7.6, 8.3.4. So we'll be conservative and we'll say 0.3. Let's say 3.3. Okay. 215. Okay, let's have a look at the answer here for 187. Since it's an odd one, we have the answer here. Yeah, any answer less than 0.39. So my 0.33 will do the job then. Great. Okay. Right. Now we can do that next batch. Okay. Use the precise definition to prove the limits. Okay. 187. So the definition is for all epsilon greater than 0, there exists a delta greater than 0 such that if um, x is close to a, then fx minus L less than epsilon. So that's the general definition for a limit of for limit, the limit as x tends to a of f of x equals L, we need this. Okay, so for 188, let's see now. Basically, the way these proofs work lies on being able to find the delta for a given epsilon and function and limit and so on. So as long as we can find a delta from the other givens that satisfy this, then we've done it. But basically, these problems come down to finding the delta. Let's see. Absolute of 5x plus 8, 5x plus 8 minus 18 less than epsilon. 5x minus 10 less than epsilon. 5x minus 2 less than epsilon. Epsilon over 5. So I'm thinking delta equals epsilon over 5. Now I don't have to do it, but let's test it. So if I have epsilon equals 0.1, then that would mean delta would equal 0.1 over 5. Well, let's make let's make it yeah. That's 0.02. So as long as x minus 2, as long as we're no more than 0.02 away from 2, then we should be within 0.1 of the limit. Let's check the upper end. If we calculate 5 times 2.02 plus 8, that would be 10.1 plus 8. That would be 18.1. So oh, actually I couldn't quite pick 0.02 because I have to not be equal to, so we could say like 1 and many nines. So this would be 1 and many nines, 1 and many nines. So yeah, it looks like we're 0 and many nines. No, it looks like it works. Sorry, I made a mess of the decimals there. But this seems to work. So that's the key. Yes, there does exist a delta for a given epsilon. So we do have the limit as x tends to 2 of 5x plus 8 equals 18. Okay, let's try 189 now. So let's see again if we can find this delta function. X squared minus 9 over x minus 3 minus 6. Now x can't be 3 in the formal definition because of this. Because if x equals a, then this would be 0, which we're not allowed, which is good. which is good. We need these intervals to be open. I didn't emphasize that last time. Actually, I was thinking that it could be zero, but it can't. Now that I think about it, it has to be open on both ends. Um, so that would be x plus 3 minus 6. X minus 3 less than epsilon. So this here, this is like, you can compare it, this again, it's like x minus a less than delta. So in fact, the delta function that would do the job is actually just the value of epsilon, which is actually really, really interesting. So if you want to be within 0.1 of the limit of 6, then your x needs to be within 0.1 of 3. I wonder what the answer is at the back. Yeah, there it is. Delta equals epsilon. Okay, good. 190. Absolute. 2x, x minus 2, x minus 2, 2x plus 1, 2x squared minus 2, minus 4x plus, yeah, minus 5 less than epsilon. Okay. 2x plus 1 minus 5. So that's 2x minus 4. 2 x minus 2 less than epsilon. So over 2. So again, comparing that with the need that x minus a less than delta. So the delta function would be epsilon over 2. Yeah, that should do it. That should do. Yep. Okay. 191 x or minus 0 less than epsilon. So x4 less than epsilon. X less than the fourth root of epsilon, or to be, yeah, x minus 0. So you can see that the delta will be the fourth root of epsilon. Yep. Okay. Let's clear this off. Okay. You still got sound? Yeah. Okay. 192. X squared plus 2x minus 8 less than epsilon. Interesting. More interesting now. 4 and 2. X plus 4. X minus 2. So x plus 4 times x minus 2 less than epsilon. X minus 2 less than epsilon over x plus 4. So this x plus 4, this would be less than epsilon over the minimum we can make x plus 4, which is equal to the epsilon over the smallest x could be would be x minus delta. Actually, maybe I want to change this into epsilon over x minus 2 plus 6, which is epsilon over delta plus 6. Could be plus or minus delta, so 6 minus delta. So I think I'm going to try and solve, but I feel like this would get an answer, but I'm not sure if it's the best way to get the answer. If I solve delta equals epsilon over 6 minus delta, 6 delta minus delta squared equals epsilon delta squared minus 6 delta plus epsilon equals 0. Get the delta is 6 plus or minus, let's go with the minus 1, square root b squared minus 4ac over 2. Would that do the job? I'm happy with that proof. I'm going to go back to see if I can do it in a nicer way. I'll pause it for a few seconds to just have a think about it. Okay, I've paused for a minute just to have a think about it. I think what I'd like to do is change this to x minus 2 plus 6 times x minus 2 less than epsilon. So I'm multiplying this out. That'll be x minus 2 squared plus 6 times x minus 2 less than epsilon. Now, x minus 2 squared plus 3 squared, x minus 2 squared plus 6x minus 2, okay, minus 9 less than epsilon. So I want this guy here to be less than epsilon. So this should be at most epsilon squared. Yeah. So if I say then this is x minus 2 plus 3 squared minus 9. Oh yeah, sorry, that should be less than epsilon, or because the absolute more than minus epsilon. Okay, so minus epsilon plus 9 should be less than x minus 2 plus 3 squared less than epsilon plus 9. If I square root everything, square root, then minus 3 to both, minus 3 plus root 9, okay, minus epsilon plus 9 less than x minus 2 less than minus 3 plus epsilon plus 9. Okay, now we have to go, we want to collapse this back down into an absolute. We'd have to go whichever of the two is smaller. Okay, now we know that epsilon is a positive, so we know that this will be 9 plus a positive, and this would be 9, a little under 9. So this side is the bigger side, and this is the smaller side. So we prefer the delta to be smaller if we had a choice. So we can turn this into absolute of x minus 2 must be less than root 9 minus epsilon minus 3. So the delta is equal to root 9 minus epsilon minus 3. Now, I want to check this. I mean, the last time I did a question like this was first year university, which unfortunately, what? Oh my, that's 21 years ago. Okay, let's check if this is right. I think I'd like to maybe I could do a calculation here. Okay, so let's define our function. F of x is x squared plus 2x. Okay. Right, now let's suppose, as an example, I want to be within 0.01. So the delta then would be, let's just take out my calculator here, root 9 minus 0.01 minus 3. So the delta will be actually quite small. Oh, but the problem is it's a negative. I forgot about that. Because of the minus 3, we actually might want the other one. Yeah, I see it. Okay, I forgot about that now. Yeah, I should have put absolute on this now. I think that would solve the problem. I'm making the smaller of the two a positive. That would definitely have me close enough, I hope. Okay, so 9 minus 0.01 minus 3. Okay, so that would make the delta equal to 0.001667, and there's more. So let's pick an x like 2.001667. And if I don't have the decimals after the 7, then I'm within the delta of the x. So hopefully I should be within 0.01 of 8. So let's calculate that. 2.001667. Okay, does that have me within 0.01? Oh, I'm a tiny bit, ever so slightly over. That's a real pain. It means I have a tiny mistake somewhere here on this one. I feel like it's just near the end. Okay. I think, you see, what I remember from 2 decades ago is a min function. So I think it's something like min, whichever of the two here is smaller, absolute of -3 plus root 9 minus that, or absolute of -3 plus root 9 plus epsilon. Okay, so if we test it out again with epsilon equals 0.01, then delta would equal min of minus epsilon, min of 0.01667, and there's some more, or one, this explains it, 0.0, I'm missing a 0 here, 3 zeros, 0.001, 0.01666, etc. So let's try x equal to 2. So that would be the 0.001666, and there's more. So we'll try 2.001666. Let's calculate that. Yes, now we're talking. We're within 0.01. Yeah, okay, that's a toughie. There we go there. I can try and graph this out on the number line to explain what's going on. I can try. So here you have x, oops. So here you have x minus 2. And it needs to be less than this number on the right, but more than this number on the left. And it's not necessarily symmetric, so I could exaggerate it a little bit by putting the number on the left over here. What we need to do is to change this into an open symmetric interval from here to here, so it becomes x minus 2 less than delta. So basically the radius of this should be less than this left distance. You should pick a radius less than the left distance, less than the right distance. Could equal the smaller of the two would do, actually. It could equal as long as it equals the smaller one. So you want the OR to equal the smaller of the two distances. And to get the distance, so we're not worried about negative, we have to use the absolute then. Oh, memories are coming back. I learned this now 20 years ago in Trevor West's class in Trinity. Yeah, happy memories. Okay, well, I think actually that's a good tough one to finish on. And we've confirmed that it works, at least for one value. So I'm satisfied now I have the right answer. Yeah, yeah. I might be able to drop them in if I could figure out which one of the two is always the smaller, but it doesn't matter. It's a function that works to give me the delta for a arbitrary value of epsilon. So I'm happy. I'm happy, and we'll finish it there for today because I'm well over time. Thanks for watching. Any problems, let me know, and I'll see you next time.